Welcome everyone. There's folks still joining, so we'll wait a couple more minutes and then we'll get started. Not too much longer. You'll probably see folks transitioning from other meetings, so I think it'll stable out soon. All right, I think I'll get started. So welcome everybody to this panel session titled "The Role of Driver Monitoring Systems in the Journey to Automotive Autonomy." This slide is really some housekeeping items, right? Today's presentation will be recorded and will be available within 24 hours on the ARM DevSummit site. We welcome your comments and questions for the speakers. The format today will be about 30 minutes of questions that I'll have for the two experts that I'll introduce here shortly. And then we'll have 15 minutes of Q&A for the participants to ask questions as well. So when you want to ask a question, please raise your hand and then I'll call your name and you can unmute yourself. And so we'll go, or you can simply type it in on the chat window, and then I can read it for you if you're a little bit shy about being on the audio. There's a link there for the code of conduct on the ARM DevSummit site if there's questions there. And then if there's happens to be an issue with getting disconnected, please try the same link. Otherwise, you have to wait a few minutes and then the ARM DevSummit folks will put up a new link if needed. Okay, so I'm gonna dive right in. Next slide, please. So a little bit about myself. My name is Daniel Bernal. I work for ARM as a solution architect in the ARM Automotive Solutions team. We're lucky to have two experts in this area of expertise. Welcome Eyeris Steinberg from Eyesight. He's VP of Research and Development. He joined Eyesight in 2012, taking responsibility for mapping and optimizing Eyesight's gesture recognition algorithms to various architectures, including DSPs, GPU, and ARM platforms. Eyeris has led the hardware and software development of Single Q, that's Eyesight's gesture recognition consumer device, and also taking responsibility as chief architect on that. Since 2017, Eyeris has served as VP of Research and Development. Eyeris joined Eyesight after 10 years at Freescale Semiconductor, where he served in many managerial roles. So welcome Alvin Wong from Eyeris. Alvin currently serves as Eyris's Executive VP for Automotive and Chief Strategy Officer. For the past decade, he has held several executive roles in the automotive imaging industry, where he defined the first generation of CMOS image sensors for autonomous and highly automated vehicles at Sony, On Semiconductor, and Athena Imaging. Alvin is now focusing his attention on in-cabin monitoring technology, where he believes AI will play a key role for safety and comfort in the existing and future vehicles. So we'll dive right in and we'll get started. So the automotive industry is moving into a phase where legislation will mandate DMS as part of ADAS systems. I think we can all agree this will add a much needed layer of safety in the cockpit. Time and time again, we have seen events where drivers cannot be trusted to do the right thing. And I believe this is where DMS plays a role. Today, we're here to talk about solutions though, right? So specifically, solutions to the issues of distracted driving and operator fatigue. This is a topic that has become an important decision, most recently due to the fact that we see automated features being deployed as part of ADAS Level 2 and Level 2+ capable systems. So the first question for the panel members are, what would you say to those vehicle owners and operators who have some reluctance to constant real-time monitoring in the vehicle when these advanced features are enabled? Maybe comment on the privacy implications. I'll let Alvin go first.
Yeah, thank you, Daniel, and thank you for everyone's time in attending this session. Yeah, for us, we realize and support that privacy is key for many people. And we feel for driver monitoring or even occupant monitoring, privacy can be done as well. What we do at Eyeris is we process real-time video on the edge, and we do our analytics on the edge without storing any video or images. And our output are metrics that have no self-identifying features. We send raw data to the vehicle's CAN bus. And again, those signals don't include any videos, names, or personal details. So we believe that privacy can be respected while optimizing active safety and comfort.
Thank you for that. Erez, what's your take on that?
Yes, I agree with Alvin, and we employ similar techniques. So all the processing is done on the edge device. We don't utilize any cloud. It's also for such safety-related applications. Cloud compute has inherent problems with latency and reliability in terms of if the connectivity is not there. But I would also tell to people who are reluctant to have such systems, I would remind them that if you look at research done by NHTSA, for example, 80% of accidents are caused by distractions. According to AAA, 21% of fatal collisions are caused by drowsiness. So it sounds like it's maybe it's impeding their privacy, but it could potentially save their lives. And I could honestly tell you that from my private experience driving as when I was younger, I wish I had one of those systems in my car. And luckily, I found myself in the right shoulder, not on the left side of the road.
Yeah, that's a great point. And it seems to me that the advantages far outweigh the disadvantages or the I guess the issues with privacy, right?
Yeah,
that's my take on it anyway. So
yeah, and just ready to say that companies take privacy very, very seriously.
Yeah, thank you. All right, so next question. Can you share what you might consider are the most difficult challenges in qualifying DMS systems to meet ASIL requirements? And what is the importance of safety qualified processing elements and safety APIs to support the processing requirements?
All right, you want me to start?
Yeah, Erez, go ahead, sorry.
So I would first distinguish between two types of monitoring systems and warning systems in general in vehicles. So the basic systems that just provide warnings to the driver are generally not considered functional safety systems. So they are rated ASIL QM. When you go into more complicated system where you have handoffs between the autonomous mode and the standard driving modes, there we see these systems being classified as an ASIL A or ASIL B, depending on the higher analysis that's been done by the tier 1 OEM. Obviously, once you go there, you have to have the proper hardware, and you have to use the tools that are certified, and you have to take care of everything that's related to functional safety. For us, because it's computer vision based, and a lot of this is based on machine learning, one of the most difficult parts is actually that the standards themselves don't relate to machine learning specifically. So there's no agreed methodology how to ensure functional safety in a machine learning or deep learning environment.
Mm-hmm. Yeah, that's a great point, Alvin.
Yeah, actually, from our direct experience with customers, we really see three challenges in discussion with them. I think the first challenge is that the entire driver monitoring system has to meet the ASIL requirement. And what I mean by that is not just the hardware, but software and the associated system. So the whole entire system takes effort and actually a lot of coordination between hardware and software providers with the system integrator. And from my past experience and learnings, especially with vendors from the outside ADAS, there's a lot of discussions between, how to put in redundancies in some of these systems, and making sure the video is not frozen or flipped so that your analytics can be accurate, things like that. So there's actually a lot of learnings that one can take from just doing outside ADAS that can be applied also for the in-cabin as well. And that's the first thing, is that, you know, the whole challenge is really how to implement the entire system. The second challenge is when you do add these redundancies in the system, how do you keep the cost down? Because when you add redundancy, whether that redundancy is in the die, in the chip, that increases cost. So you put redundancies in the software size can increase. And then as you add more of these redundancies, you might require more computational power. And so these are things that are challenging. So from a system perspective and engineering, you know, how do you harmonize the hardware and software together so that together then they can pass ASIL and keep the cost down? The third challenge that we run into with some of our customers is that when you add additional sensors, not just cameras, then you require even a bigger scope. And then how do you coordinate all of these other sensors like a radar or thermo, which are mainly secondary sensors to the camera. But again, all of them from a system perspective, how do you manage all those other things and put it in one ASIL, you know, passing one ASIL system? So those are the three challenges we see and experience with our customers so far from the ASIL perspective.
Yeah, it's a great point. I'm sure if you don't live and breathe this on a daily basis, it's difficult to appreciate the complexity, right? All right, next question. Can you share your thoughts on how traditional computer vision techniques are used in conjunction with deep learning in DMS systems? And are there areas or certain tasks of a DMS where hybrid approaches work best?
Yeah, that's a great question. Yeah, that's a very good question, Daniel. I think whether one decides to use a machine learning approach or a deep learning approach really depends on the application and use case. But that being said, I think the common end goal is how do you achieve the speed and accuracy that's desired? You know, I think we all can agree that machine learning is really good at solving simple linear problems, and this could be as simple as is a seatbelt on or off, right? That's pretty simple. But when you think about more complex nonlinear problems, that's where deep learning can shine. When you think about determining head pose with different camera locations, things get a little bit more complex. And then some things in deep learning, some advantages could be you can do transfer learning, and you know, fine tuning can be done effectively. So I think depending on the problem that you're trying to solve, whether it's a simple linear issue or a nonlinear problem, determines whether you want to do a machine learning approach or a deep learning. But at the end of the day, again, the common goal is how do you get the speed and accuracy? Because what you're fighting against is latency, and also trying to achieve the best accuracy with the lowest power. Because you know, a lot of the new cars are going to be designed in under EV cars, and power is everything. So I think those are the type of things that one should consider when looking whether to use what approach based on the problem they're trying to solve.
Yeah, great. So Erez?
Yeah, so I think there's a small misconception about deep learning in general. A lot of people think that it's a replacement for the conventional computer vision techniques, but in fact, it's basically just another tool in the tool bag. It's a great tool. We've seen it do amazing stuff over the last few years when it's, you know, ramping up with all the latest achievements. But again, it's a tool, so you need to know when's the right time to use it and for which applications. I'll give some examples. So for example, if you look at classic computer vision application where you need to track objects, so this can be done with neural networks. There are really great ways to do that. But in order to do that properly, you have to have the proper data sets and train it correctly and validate the networks. And there are classical optical flow methods that work really well and are very well proven. And also, generally, they're cheaper than deep learning in these kinds of applications. I can give another one, for example. DMS cameras are usually mounted in front of the driver and sometimes on the steering column. And the camera needs to know where it's positioned in the vehicle and its orientation. But the steering column can move. You know, drivers adjust it to their sitting position. So the camera has to recalibrate by itself. Honestly, I don't know of a deep learning method to do that, but there are classical computer vision methods to do that properly.
Yeah, that's a great example. Okay, next question. Are you able to share any insight into requirements or legislation that demands logging of DMS system alerts for either for after action review in case of an accident, for example? And what happens to that data once it's collected? I'll let you go first, Erez.
Actually, we're not aware of such regulatory requirements, at least not for the OEM market. In the aftermarket, there's no regulation really, so companies can come up with telematics boxes that have DMS capabilities, and then they can record videos and send it back to the fleet managers. We haven't seen vision-based DMS being adopted as something like an insurance telematics where you can get graded and then your premium could change based on your driving behavior. But we haven't seen that really take hold, so there's no set process for that.
Okay. Alvin?
Yeah, from our side, we're still early in the discussions, but we are in talks with insurance companies about, and some OEMs, about the possibility of putting a black box in the car. And there's several reasons why this discussion is taking place. But as I said, it's pretty early. The first is that the data can be used to inform emergency crews. For example, the number of passengers in the car. With our analytics, we can show the body movement, the upper body movement, how the body had moved during that crash, and then that can be shared with the emergency crews as they're going to the scene. Even with some of our analytics, we can talk about, if there's a small child in the front seat, so it gives them a chance to strategize before getting there. Along with that data, especially for insurance companies, they can also determine if the driver was distracted before the accident, things like that. So there's a lot of discussions happening from that perspective. But I think in all these discussions, I think that we're involved with, there is a thing about harmonizing the outside data with the inside data. So for example, of course, you're always trying to avoid accidents as much as you can. There's going to be some cases where you can avoid it. However, you can predict where maybe the accident may happen. It is going to be a front crash, a rear end or side crash. And because now you have data inside the car that was never there before, you can now strategize proactively how to prepare the cabin to maximize safety. Do you deploy certain airbags at certain times, depending on the size of the passengers, where they sit, and the type of hit that's kind of predicted to come in? This is really rich data now. All of a sudden, this really is a game changer in terms of now preparing the cabin versus just, in today's cars, just deploying airbags because you got hit. That's just not a very smart and intelligent way to do so. But now with the data in the car, with outside data harmonized, I think it's really going to be a game changer on how to, really provide safety for the passengers inside the car.
That's a great insight there. I appreciate the informative answer there. I'm learning as we go here. So, all right, so we'll go to the next question. Can you provide any insight into driver health monitoring capabilities and their importance to a DMS system? Do you see any advances in this area that will play a larger role in your solution? And is there a feature that would be implemented more likely in an ELF level 4 or level 5 system? Alvin, yeah, sorry.
Yeah,
ahead, Alvin.
yeah, no, I'll take that if you don't mind first. Yeah.
Sure.
But I think as anything, I think we can all agree that the in-cabin space is really kind of an emerging technology, and it's just going to get more sophisticated from this point on. And there's going to be a lot more innovation that happens. And of course, AI is going to play a big part of that, machine learning, what have you. As we know, driver monitoring system today is actually pretty basic, especially with just eye gaze. But you're going to need a lot more information. When you think about, you're mentioning driver health monitoring, we're working with some of our customers where we've already added additional sensors like radar and thermal. With radar detection, you can do some heart rate, respiratory presence detection, which has already been proven you can do with radar. With thermal sensors, you can do temperature signatures of data for a dog, human, pet, or cat. So all these sensors can provide additional information. In our discussions with some of our customers in the R&D department, there is a general consensus that the driver monitoring and even occupant monitoring can be a big differentiator for them. And so, some are planning to accelerate their efforts here to get this in-cabin monitoring feature up running faster than normal. One case in point, what I found when there was government regulations for putting rear view cameras in a certain amount of percentages in the car, a lot of OEMs started putting that in their cars, but they actually beat the number of adoption of rear view cameras because the customers really love the fact of being able to see with a rear view camera now. And so they found that feature to be very big differentiating, and then that just took off very quickly, like gangbusters. And I actually see in-cabin, the benefits doing really well. I mean, I have a 16-year-old son who's about to get his driver's license. And, they're always, these younger generations texting and always the social media. And, my wife and I would definitely want to buy a car where the car could help my son, hey, pay attention back on the road or take over the driving and things like that. And I think there's just a lot of benefits for this in-cabin monitoring. As we talked earlier with the first questions about, privacy, as Eyesight and Eyeris, we respect privacy in a lot of stuff that we do. As we mentioned, we do things on the edge, and we just think there's going to be just so many additional benefits for safety of the passengers and for the the entire the car inside, and so that's what we're really excited. And we think in-cabin is going to be big. We're just at the very beginning of it. So as you mentioned, the health monitoring capability is going to get better as we go further into this in-cabin monitoring space.
Thank you, Erez.
Yeah, I completely agree. I think in-cabin has a lot of potential in a lot of areas. I think specifically, if we talk about even the near-term roadmap, look at Euro NCAP. So they're working on distraction drowsiness, but the next thing on their roadmap is called sudden sickness. Basically, it doesn't have a proper definition, but you can think about it as people might have strokes or heart attacks while driving or lose their consciousness. In that case, the car, it would be, it would save their lives if the car would be able to detect that and pull over, call emergency services, and so on. So that's definitely on the roadmap. Besides that, I saw applications where, because people drive basically every day, so the car is a great place to actually measure their vital signs. So you can check their respiration, heart rates, and so on, blood pressure. I think Byton was showing that a couple of years back. I'm not sure if that will catch because everyone has smartwatches today. They do the same thing, but that's another application that I saw there.
Yeah, that's a great point. All right, we're going to keep going here. We have about 7 more minutes.
Yeah.
What is the importance of determining, are you able to provide any insight or designs you have seen from OEMs on the transfer of control from automation back to a driver? And specifically, how are visual alerts and audio alerts used for a smooth transition? I know this is probably a little bit outside of your area of scope, more an OEM thing, but I'm really curious on how you've worked closely with OEMs on this capabilities. Erez?
Yeah. So first, I think there's a general agreement among tier 1s and OEMs that L3 handoff has to be backed up by a DMS system to make sure that the driver is capable of taking control of the car. I know that in Japan, there's an initiative to promote autonomous driving, and that includes a driver monitoring system. In general, we saw that the handoff process would start with an alert. That would be either a message or a beep from the vehicle once a section of the road ends and the autonomous system has to disengage because of road conditions, or maybe you're approaching on an exit. And the driver would be expected to take control of the vehicle, at which point the autonomous system would disengage. After that, there's an escalation path. So if the driver doesn't take control, it will beep louder, vibrate the chair, and so on until eventually, if the driver doesn't insist of not taking control, the car will stop, will pull to the side and stop.
Erez. I'm sorry, Alvin.
Alvin, sorry.
Yeah.
We look the same, right, Erez?
Yeah.
Yeah, I think what we've learned so far is that the human-machine interface between a human and any machine really has to be natural and feel second nature to the user. And if it's not done properly, the user is not going to enjoy the feature, and they're going to reject it, honestly. And as we all seen, as early back in 2007, Apple spends a lot of time and effort to harmonize their hardware and software such that the HMI is very natural. And that's why I believe the iPhone was such a big success when it launched. And so I think it just really shows that the human-machine interface is so critical. And I think the work that we're doing for the in-cabin space really can help the OEMs determine whether to give control to the driver or let the car take control. But it has to be done in a very thoughtful and really managed well, because if it's not done well, people will not want this feature and they won't even buy the car. I mean, you can imagine if people were telling on social media, man, this car just took over and got me in an accident, I want to take over. That's really bad for that OEM. And so that's why the OEMs are really seeing this as a big differentiator as a human-machine interface, and they have to get the data correct for the in-cabin, what's going on with that driver, their cognitive state and all that stuff. It's becoming that serious because everything's going to come down to the HMI. And that's been our experience so far working with our customers.
Yeah, that's a good transition to this next question is what is the importance of determining cognitive state versus simply reporting physical parameters of the driver, right? And how does your solution differentiate in this regard? I'll let you go first, Alvin.
It just extends to what I also said earlier, is that the HMI experience is really important. So for example, if the DMS system thinks the driver is sleepy or not capable of driving the car is going to take over. However, if it was wrong, you can imagine the driver would be very upset about that. And so, for example, some of the driver monitoring systems today, really look at eye gaze. Eye gaze only is not the best way to determine what's happening to the driver's cognitive state. You're going to need a lot of other inputs as well, especially if you only depend on eye gaze, having sunglasses polarized, you can't see the eyes. Or if you're wearing a hat, or there's gonna be a lot of things that block it, especially as Erez said, if you have a camera on top of your steering wheel, your hand could block it, or if there's sun blocking it. I mean, just a lot of things that would make that very ineffective. So there's a lot of other things that need to be looked at besides eye gaze, because you really want to get the cognitive state correctly. That's how important it is, as I mentioned earlier, for the HMI to work well between humans and machines working together.
Yeah, Erez?
So I agree that the cognitive state is our ultimate goal, but the physical parameters are the things that we can actually observe directly. So we can in computer vision, we can estimate the gaze, the head position, see if the eyes are open or closed. And a lot of these are pretty straightforward. If the eyes are closed for 2 seconds, the person is either asleep or not paying attention to the road. And based on these, we can estimate some cognitive states. Okay, so we can estimate the drowsiness or fatigue of the driver. There are other hints to the cognitive state. If you can be looking forward, but you might be daydreaming completely and not paying attention to the road. So you need both of them probably to have a complete system.
Okay, yeah, thank you. So ARM technology, right? And ARM is a technology provider. What does ARM provide that has made develop easier for a DMS system? It could be anything that you can think of where, maybe you prototyped on a different platform and brought it to ARM, or started development on ARM initially. What's made the experience good for you, or I guess any gaps, right, that you may see in the ARM ecosystem? Erez?
Yeah, so I think first, ARM makes excellent processors, so that's the first thing. So really, the CPUs, they provide, we typically use the Cortex-A family. They provide a lot of CPU processing power and capabilities to vectorize and optimize the code with Neon. So that's very important. And also, the fact that most of the ecosystem of these SoCs is based on ARM makes our job in that aspect pretty simple. It's easy to retarget different processors, so that's very easy for us. Another couple of things, ARM provides reference libraries. So there's the compute library that has optimizations for the ARM and also the OpenCL optimizations for GPU, which make it easier to port on ARM platforms and optimize, plus the ARM and N libraries, of course. And also there's the development tools. DS5 has a really good optimizing compiler. It's crucial for functional safety because it is functional safety rated. And it has a great built-in profiler to see the performance and analyze any hotspots and so on.
Alvin?
Yeah, as I mentioned earlier, I think harmonizing the hardware and software is really key to run efficient and effective systems. And Eyeris is an ARM partner because ARM's technology is embedded in many automotive systems today. And processing our deep neural networks efficiently is critical for performance, but also power consideration. I think we all know that the CPU is central to all AI systems, whether it's handling the AI entirely or partnering with co-processors such as DPU or NPUs for certain tasks. And as the demand for powerful compute accelerates, ARM's common architecture supports diverse AI applications, which allow seamless integration with existing neural frameworks as TensorFlow, Caffe, Android neural networks. And so really we see as ARM as a really good partner in helping the in-cabin monitoring space move forward.
All right, thank you. So let's take a couple minutes and we'll let you take, make a couple statements on what makes your solution unique in this space. And I'll start with you, Erez. And then we'll go with Alvin. And while you're doing that, I'm going to look at the questions to see what has come up from the panel. So go ahead.
Sure. So maybe briefly, I think Eyesight, has been developing computer vision software for really over a decade. We've accumulated a lot of experience in developing classical computer vision solutions and really optimizing for embedded platforms. And that's one of the things we can see on our DMS solution as well. We were able to combine deep learning and classical computer vision to create really a competitive product that minimizes the system cost in terms of the CPU requirements and also requirements for the system itself, like the sensor resolution and so on. Also, I think, we focus on two markets basically. So there's the OEM market and there's the aftermarket industry. But our development is oriented towards the OEM market. So both of them gain from our development processes that are very automotive spice oriented, functional safety, and the extensive validation that's required for an OEM product.
Alvin?
Yeah, for us at Eyeris, we've been living and breathing the automotive in-cabin space since we were founded in 2013. That's always been our focus. We've not ventured into any other market, so this is our focus. The vision back then continues to be, cameras with the main sensor and maybe other supported sensors like thermal and radar to really provide the best and most in-cabin scene understanding. I mean, that is really our goal at Eyeris. And we believe in really three items that really make us unique. The first one is that we really take a system level approach. And as I mentioned earlier, hardware and software working in harmony is key. And what we like to provide our customer is the flexibility of the hardware, camera placement, what have you. And so we work with many hardware partners in the processing unit. We work with hardware partners in the cameras. We work with ISP partners. We work with lens supplier partners. Because at the end of the day, our customers have their preferences, so we wouldn't be hardware agnostic. So we have a lot of flexibility from our system design. In fact, because of this experience, a lot of our hardware partners are actually coming into us to help them define their future roadmap. The second thing that I think that really makes us unique is that we always are utilizing the most advanced AI deep neural networks. As I mentioned earlier, we want to continue optimizing performance, reduce latencies, reduce power, just be really efficient, because I think that's where the market is heading. And so we do things like usage of quantization, pruning methods to make our code even more effective so we can rely less on the computational load from our hardware partners. And the third thing that I think that makes us very unique is that we're innovating at a very fast pace. Last year in 2019, we were the first company to demo a in-cabin demo running multiple deep neural networks on an AI chip running with parallel cameras simultaneously. And then earlier this year at CES 2020, we were the first company to show in-cabin sensor fusion AI, where we ran multiple cameras, radar, and thermal sensors. So I think those three things are hardware flexibility, working with partners, looking at the overall system, using advanced AI deep neural techniques, and just moving fast in this space, I think really helps us kind of make a unique value proposition for our end customers.
All right, thank you. We're going to open it up for some questions if you guys are okay with that. I know in the comment field, there was a comment about, I think based on the privacy question early on, Jay Penny's made a comment, no one believes the government isn't going to vacuum up this data as soon as possible. Can we can talk pretty, but please let's not lie to each other. I think it really comes down to legislation, right?
Yeah. They're listening now.
That's a good point. What else? Anybody wants to unmute and ask a question, you're welcome to at this time.
Is there any particular facet of each other's company that you would appreciate or like to integrate into your own?
Is the question, is there something that maybe Eyesight has that you're thinking that we might want, or vice versa? Is that the question?
Yeah, essentially.
Yeah, I don't actually have, let's say, firsthand experience on Eyesight's capabilities. From that might be better questions for our end customers, actually.
It probably is.
Because I think, honestly, we'll also be biased towards our own solutions, but I think that's a better question for maybe the end customers.
Yeah, that's a good
That's
point.
quite fair. Thank you.
Nelson.
Yeah, I have a question. So one concern that comes to mind is basically at the end of the day, these systems are trying to coexist with a human driver, and what happens when they want to do something different than the human driver. I mean, one example that comes to mind is the Boeing issue where it was a couple of months back, where the sensors thought it was there to save lives, right? It was there to stop the plane from crashing, and the sensor thought the plane was crashing, so it tried to pull up the plane, but it turns out the sensor was wrong, and the pilot was actually struggling with the controls to stabilize the plane, right? So at the end of the day, how do you deal with an issue like that, right?
Erez, you want to take that one first? Or?
Yeah, so I think first, in terms of the ecosystem, the DMS vendors usually provide the capabilities to detect the state of the driver, but the OEMs make up the decisions on how to act on the outputs that we provide. I think it's unlikely that the vehicle would intervene without giving a warning or being very, very confident that it has to. Like, for example, if a driver becomes unresponsive, then the system won't just take control. It might engage some low form of adaptive cruise control and lane keeping assist to make sure that the car stays in the lane. And it would try to prompt the driver to take control back of the vehicle to see if they're responsive. And only if they're not responsive for some time, then the vehicle will intervene more seriously than that.
Yeah, I agree. I think, there's always going to be corner cases. I think from my experience from the ADAS, looking at the outside, there's always a lot of cases, and I think we learned from that. I think there's just going to be a lot more sophistication as this technology, as you said, this is, in-cabin space is fairly new to most people. AI is fairly new. It's just going to get more sophisticated. So as it gets more sophisticated, I think it's going to get a lot better as we go forward.
Robert Day actually had a couple of questions. I don't know if you want to unmute or you want me to read them, Robert.
Yeah, I can unmute.
Yeah.
Probably a quick one for you. I'm intrigued as to how you're going to pivot from a DMS to an OMS when there's no driver in an autonomous vehicle. If you have a robo-taxi, you're already thinking about the use cases around looking at the occupants, passengers versus drivers.
Yes,
Yeah.
for sure. So go ahead, Alvin. Go. Sure.
Okay, no worries. Yeah, so as I mentioned, for the start of Eyeris, we actually didn't start as a driver monitoring. We've always wanted to get a feel for what's happening for the in-cabin. And so, like, for example, depending on the camera placements and the field of view of the lens, you can determine how many passengers are in the car, what have you. As you mentioned, it's a very good question because the dynamics of the car are going to change. You know, when you're going from a level 2 all the way to fully autonomous, all of a sudden you can change the seating positions, and that's why we talked about active safety, because the airbag standards would be different if the seats turned around. And so having this whole understanding of the in-cabin, it becomes critical when you think about that in the future.
Yeah. Also, if you look at all level 4 vehicles or robotaxis and so on, there are other things to monitor except the safety of the driver. There are a lot of convenient features that are required. So, for example, checking that the passenger that is in the back seat is actually wearing a seatbelt and not just clicked it in and moved to the other side. Or where if they forgot any objects, or maybe they're doing something they're not supposed to, like vandalizing the vehicle, and so on.
Yeah, thank you. Let's see. You have another question, Robert, or let me while you unmute.
No, you can do the other one that's there.
And yeah, and Andreas R asked, yesterday we talked about the Uber accident where the person was killed. I said, what has been done since then to avoid such issues in the future?
Well, I think in that case, it's more related to the ADAS systems or the autonomous driving systems in this case. If there was a safety driver, then I'm assuming that that driver should have taken control and prevented that accident. If we're talking about robotaxi, like I think what Uber is trying to do, then it's up to the autonomous vehicle, not to the DMS system.
Yeah, honestly, I think the lesson learned there is that it shows the importance of actually having some kind of in-cabin monitoring system. Right. I don't believe the Uber car that got in the accident had any for the inside. If there was a robust in-cabin monitoring system, they would have realized that the driver wasn't even paying attention and looking at the phone. And then there definitely would have been a lot of warning signs. So I think lesson learned there is that it shows the importance of having a very robust in-cabin monitoring system.
Yeah. I think, I don't know the specifics of this one, but if you look at a lot of, the headlines Tesla makes sometimes, usually the driver is asleep or not paying attention or drunk or something.
Yeah, that's a great point. Inattention or not at the right cognitive state for sure.
Yeah.
Anybody else want to unmute and ask a question? We have a couple of minutes left if somebody's brave enough or has a pressing question. I'm going to ask the last one that Robert had. It says, does the processing of DMS have to be separate to the ADAS/autonomous system? Or could the DMS camera be just another sensor feed into the ADAS/autonomous compute system? What's your take on that, guys?
No, it doesn't. It in a lot of cases, it's a separate ECU that does only the DMS. There are cases where it's combined on the same system. Specifically, Eyesight works with Mobileye. We're integrated on their IQ chip. It's not ARM-based, so I won't elaborate. But yes, we do that.
Yeah, I think at least from our experience, obviously having both data sets are important and harmonizing that data. But I think before even harmonizing that data, you have to make sure each component itself is accurate. So making sure the in-cabin stuff is good and sound, and then you can integrate that with other parts of the data on the outside, then you can make some really good decisions. So I think that's the approach.
Okay, and with that, we'll close the session. I greatly appreciate everybody attending. We have contact information there for Alvin and Erez. Feel free to send them email if there's a pressing question or something that you need to contact them for. And then if there's any interest in the ARM's AI ecosystem, please reach out to Mary Benyon. Her email address is listed on this slide as well. Appreciate the attendance, and we hope you have a great ARM Developer Summit. Thank you.
Thank you, everyone.
Thank you. Bye.